Thanks for joining us for another episode of DPC Radio. This episode was recorded live in Amsterdam at the Dutch PHP Conference 2012. For more information about the Dutch PHP Conference, visit our website, phpconference.nl.
So, welcome to my talk, Redis for the Everyday Developer. So let's get started. Let me turn on this remote. That will help. By way of introduction, the fellow who forgot to turn on the remote is Ross Tuck. I'm a team lead here at iBuildings Utrecht. In addition, that makes me senior engineer, occasionally API specialist, headgear consultant, diversity hire. Now I'm obviously not Dutch, but I know some of you are. So if I go too fast, even though we have a lot of material to cover, just please yell at me. Stupid American seems common, but not always effective. All right. So I'm on Twitter and Freenode as @RossTuck, very creative. And that's all very boring. Actually, I'm a pretty boring guy. You know what's not boring? Redis. Redis is not boring. Redis is awesome. Redis is one of the coolest things you've been using right now. All right? Redis is so cool. It's called a Swiss Army knife, and that nickname is really well earned. You can use it for a lot of stuff. All right? So now, firstly, when you talk about Redis, most people think NoSQL. It's one of those NoSQL thingies that I use at high scale, right? And I don't really need that. But I would argue that that's not really something you need to worry about here. I'm going to pitch Redis to you today as something that's very flexible and useful for everyday situations. I'm not here to talk to you about cap theorem and sharding and writing MapReduce stuff. That's all very well and good, like NoSQL, but for all intents and purposes, this is a NoSQL talk. Right? Only one at the conference. All right? So now when you're considering a project for use, though, if it's not on the basis of I'm at ridiculous scale, there's a few things you should consider. One, is it written by a guy with a cool name? Yes, it is. It's a very cool name. Right? Two, is there a company behind it? Does it actually have funding? Is there somebody who's paid to work on this stuff? And the answer is yes, it's sponsored by VM, but it's actually used by a lot of companies. If you're in San Francisco, you couldn't throw a cat and hit somebody not doing something cool with Redis. Right? It's 3 years old. That's a fancy way of saying the bugs are shaken out. All right? Finally, it has a community. It has a great developer website, really good docs, a lot of use cases and stuff. I highly recommend you check out the website. So that's all good, but what is Redis? What does the highly informative website say about what Redis is? It says, Redis is an open source advanced key value store, right there on the front page. It goes on to say, it is often referred to as a data structure server, ... Now, the ... is not on the website. That would be a cheap ploy to add extra drama. The dots are from me. So I'll come back to this a little later on in the talk, okay? And I'll explain what's going on here. All right? Now, that all sounds well and good, but what is it actually? All right, take away the buzzwords. Redis is a database. You install it on your network. You can talk to it from one server, multiple servers, whatever. You use it to store data. It's designed primarily to exist within memory. That means that your data set should be within the size of available memory here. So if you've got 2 gigs on your server, your data set should be preferably under 2 gigs. That sounds like a really nasty constraint, but gigs is actually quite a lot. I mean, this is 2012. We got lots of memory. We can ski down memory slopes, okay? There's lots of memory here to do that, so it's not that bad. What's cool about Redis? Why I'm excited about it? Fast. Redis is really, really fast. That's the first thing that comes together. I'm going to show you a little demo of how fast Redis is. I can't. It's already done. Okay? Now that's that's a cheap joke, but the fact is that on my little itty bitty laptop here, which is nothing, I get about 120,000 simple operations a second. Okay? That's pretty fast. And that's cool, but like I said, I want to pitch it to you on the fact it's flexible, all right? That you can do a lot of different things with it. So it's also persistent. So it's key value store. You can use it very quickly. But you can also optionally write to database. You can set it to write every so many writes, every so many seconds. There's a couple different options, snapshots or pinned only. The documentation lists this stuff really well, so don't worry about it too much. But you put in a nice simple default config, your data will be persisted. All right. It also does replication, master-slave specifically. It has pub/sub. We'll talk about that a little later. As of 2.6, it will have scripting in Lua, which is a lot like JavaScript, and will allow you to add custom operations on the server. It also has transactions, which is a nice feature that many key value stores don't have. It also slices, dices, makes julienne fries. It's very cool. So you say, that's well and good, but Ross, I'm not trusting my data to your fancy NoSQL thingies. All right? I'm happy with MySQL. And that's good. MySQL is great, okay? I'm not dissing MySQL, and I'm not even pitching Redis as an alternative. I'm pitching Redis to you as a complement. That there's some things that MySQL doesn't do as well that Redis does really great, and there's some things MySQL can't do that Redis does very easily. All right, so MySQL and Redis, it's a great combo. Use them together, not as separate. It's not to say you can't build stuff entirely on Redis. Some people do, but there you go. Now, setting it up, how hard is it to do? You can just do apt-get install Redis server. Unfortunately, like many things in Debian and Ubuntu these days, this is easy but out of date. Okay, so if you want the latest and greatest, go to the Redis website, download it, unpack it, make it, and run it from the directory. You're done. It's really, really simple, okay? We need to connect to it. It's a database, so we need a driver. If you're using 5.3 and above, and you are, because 5.2 is not supported, it's end of life, then Redis is the best option, hands down. It's the most advanced, has a lot of really great features and stuff like that. Use it. It's good. If you're on 5.2 and under for some ungodly reason, then there's a backport of Redis that does varying degrees of maintenance, and there's Redisco, which is an older library. Very, very good too. Great documentation, nice guys. Just Redis has some nice features. Okay. If you like C extensions because you hate easy debugging, then PHP Redis is a really good choice here too. Actually, it has some speed gain, but it's not going to be your bottleneck. Finally, there's Redis CLI. It's a script that ships with Redis. And it's very, very handy for just connecting to the server real quick, doing a couple commands, testing something out, actually. So as a debugging tool, don't forget it. All right. For the remainder of the presentation, I'll be using Redis. And this is all you need to do in order to connect to Redis, provided it's on your local host on the default port. That's it. That's all you have to do. Okay. So very, very easy. Now, I'm going to show you about 7 use cases today of different sizes about how we can use Redis. But before that, I want to pull a little memento on you and give you a modest proposal, as it were. I'm going to go ahead and give you the surprise ending of my talk, and in exchange for removing the suspense, you guys are going to pretend that what I'm about to say is totally reasonable, and you're fine with it, and you're okay with it through the end of the presentation. We're just going to pretend, all right? Here's my proposal. All right? Next time you go out to deploy a server with the Holy Trinity, PHP, MySQL, Memcache, that you don't install Memcache and you install Redis instead. Okay? That is not to diss Memcache. It's a great thing. It's been a workhorse of the PHP community for a long time for good reason. But I'm all about the 80% cases. And my argument is that Memcache is hyper-specialized to go on every single thing that you send out. Redis will do well for most cases, and it will give you a lot more. You will find use cases for Redis simply by putting it on your server, by adding it to your stack. That's all I'm suggesting, okay? All right, so let's talk about use case number 1. If I'm going to talk to you and say that Redis is an excellent replacement for Memcache for many cases, it better be an excellent replacement for Memcache in many cases. All right, so let's look at some code. You need to know that Redis has commands. Commands have parameters. I think we're familiar with this concept. All right? It looks a lot like this. With Redis, the name of a command is simply mapped to the front here, and any parameters that has go here as arguments. So it's almost one-to-one. You almost don't need documentation for Redis. You just look at the Redis website for what commands you need and what parameters they take. Easy. All right, so the first command is set. Now, set does pretty much what you would expect it to in a key value store. I give it a key, ROS mood, and a value, nervous. Easy peasy. Now, you'll see here that I've got a colon here in the middle. That has 100% absolutely no value to Redis whatsoever. It's just that Redis is a flat key value store. There are no tables or anything like that. All your data is together. So it's very, very helpful to namespace your keys. All right? There's no real performance penalty with doing that much. So it's pretty common. And the common separator here is a colon. So please do that. It'll make your life easier. But this will actually set the state of this key to nervous on the server. Done. All right? So later on, then we do the get command. Aha, you know 2 commands now. Then we can say the same key in there, and we'll get back the string nervous. That's it. Very, very simple. Now, many caches have an extra feature, which is TTL, time to live. You put data in there, and then expires after a certain point. Redis, excuse me, Redis does this through the expire command. You just simply give it the name of the key, the number of seconds that you want it to live, and that's it. So if we just do a get again in 4 seconds from now, we'll find that the mood is still there. And if we do it 5 seconds later, we'll get back to the value of null. I guess the drugs and cocaine have kicked in. So pretty easy. All right. So this set expire feature is so common when using Redis that they've actually made a compound command for it, setx, where you can just give all this in one single command. That's it. This tactic of making compound commands is very, very common. You'll see it a few times throughout the presentation. So yeah, it's just a handy little feature. All right, so Redis is really great for caching. Depending on whose benchmarks you look at, then it's about as fast as Memcache, actually. Who is faster a little bit goes back and forth. Memcache may pull ahead a little bit recently, but it's pretty good. So it's a good option here. Also, you don't have to configure slab sizes or anything if you're storing lots of little things. It sizes the memory that it's using automatically, so it's nice and easy to set up. All right, use case number 2, session storage. To play another dirty trick on here, you basically already know how to do it. I just showed you all the commands you need in order to do it in the last use case. All right, you know how to set values, you know how to get values, you know how to expire your sessions after a certain amount of time. That's really all there is to it. I can show you code for this, but then it just basically becomes, session handlers for everyday developers. That's not too interesting. But another feature about Redis that makes this really useful and a good fit for session storage is that I told you it reads really, really fast, but it writes almost as fast. They actually appear right next to each other in the line. Okay, so if you're doing a lot of session writes and stuff like that, then Redis is going to be about as blazingly fast as you can get. Also, I once worked on a project where we had sessions that were running over a megabyte in size, and we couldn't do anything about that. You cannot store that in Memcache. Memcache has a limit there of 1 megabyte per value. Now, you got bigger issues if you're storing a megabyte in session every time, but we could use Redis, and then we wouldn't have had the problem. So, yeah. All right, so use case number 3. I want to move on real quick here. Hit counters. I know what you're thinking here. Ross, I don't work at GeoCities. Hit counters are not really a common problem for me. All right, but I would argue that's not entirely true, actually. Just it lives on in a different form. If you look at Tumblr here, you can see that they've got a number about number of comments or likes or whatever it is you do on Tumblr. WordPress gives you the total number of downloads for a given plugin. And Stephen Fry, oh my God, he's got 3 of these things. He's got number of tweets, following, followers. I mean, these are really just kind of incrementing hit counters all over the place. And if you're putting these on many, many places, then even on a small project, querying your database for these counts is going to give you a world of performance pain. All right? So Redis actually has a good feature for this. It's called Incr, which is short for increment. All right? So all you do is using Redis, you simply say, you create a key that's unique to whatever page you want to have here, and you run Incr. Incr will check first, does the key already exist? If it does not, it will set it to the value of 1. If I run Incr again, it'll set it to the value of 2. And if I set it again, anybody? We have a winner. This comes back to a hallmark of what I've been saying throughout the presentation. Redis is hard. Okay. So how is this better than simply doing a DB count over and over again? These commands are pretty useful because they're atomic. Every single command you run in Redis is atomic. I can throw lots and lots of these at Redis, no matter how many clients, whatever. It's not going to mangle my data. I'm not going to have to worry about one coming a little quicker. The overhead is very, very minimal. So this is a good way actually to do counters. I said it's fast. The Redis Benchmark suite that comes with every version of Redis has a test suite for Incr. It runs 50 parallel clients, so basically 50 people at the same time on my machine, and every single one of the requests completed in under a millisecond. It's pretty quick. So it thinks it can do about 120,000 of those, like I said, on my laptop. It's fast enough. So you can find lots of use cases for this if you're really looking for it. You can also use the incr by command if you want to do multiple at a time. And from 2.6, there will be increment by float. If you're into math stuff and you want to do scores, ratings, I guess this is useful. I'm not really a math guy. Okay, let's get to something a little bit deeper, a little bit heavier. Latest news. I'm talking about like on Google News here, right here. We've got this page, and they show the last 3 pieces of news that you're going to see right here that's customized for you. I want to talk about how we can do this a little bit more easily than you expect with Redis. So hang in there with me. I told you earlier that there was this quote. It is often referred to as a data structure server ... Now I'm going to fill in the other half of the quote. It says, since keys can contain strings, hashes, lists, sets, and sorted sets. Okay, what does that mean? I want you to picture, if you will, Redis as one giant PHP associative array. All right, it's one big array. We're very familiar with how that works. Now, earlier when I was showing you the set command, when I did Ross mood, we were just basically setting this value to happy inside of our giant associative array. Okay, and we could do the same with the key foo. We could set it to the value of 9. All right. Now, if I were using a hash, that would be a lot like having a subarray. I can put different types of sub-values inside my value here, okay? So name, age, etc. I can put, basically objects, forms, records, structured data inside Redis in a way that's easy to retrieve. And every data type, like hashes, comes with a different set of operations that make them good for particular things. So in this case, I might be able to get all the values at one time, update just one single value, age, for instance, etc., etc. So it's very useful. You also have lists. The lists are just kind of like appending stuff into one of these keys over and over again here. They come in a particular order, but they don't have any key that you can retrieve a sub-value from. It's just the value. Okay. The operations that they come with make them very, very good for building lists, stacks, queues, stuff like that. Okay. Finally, if sets. Sets are a little bit of an interesting one here. They come with a lot of operations for doing intersects, diffs, things like that. They have no order whatsoever. If I put 1, 2, 3, 4 in, they will not come out in 1, 2, 3, 4. It will come out in who knows what. But it automatically removes duplicates, and that's a very, very useful property. All right. You can use it for relations, stats, matching. You'd be surprised what you can do with these, actually. There's some great use cases online. Finally, there's sorted sets. These are sorted not by order, like with the other sets, but by a score, an independent value that you give separately. And we'll look at later on in the presentation how you can use that to do some really crazy stuff, actually. Use cases here include curing cancer, world peace. Okay. Well, they're a lot like sets, but with orders or scores, that opens up possibilities. All right. So why do I keep listing things here? I said Redis was simple, and now I'm making it all confusing and hard. All right. The fact is that one of these values up here can really, really help us with building our news application, and that's list. All right. We can use the lpush command on a particular key here to append something in. Now I'm going to use the headline, but you might use a database ID, a URL, whatever you will. All right. So we're just going to lpush in here the value aliens attack to this list. And Redis, in its benevolence, will create a new array, and we'll put the value aliens attack inside of it. All right. Now, I can do another lpush a couple hours later when George Takei announces he's running for president, and it will appear in this value as well. Now, it's probably worth mentioning that, you think of a push in PHP, it will go to the end of the array here, but in Redis, it went here. That's because there's an lpush and an rpush. Lpush will push here, rpush will push here. So it's kind of like what we would consider an unshift. All right. So again, we do it again, and there's another value. All right. So just to recap here real quick, you do 3 lpushes, you end up with this array right here, Redis. Easy peasy. You with me? Okay, cool. How do we get this back out? Because it's quick, fast, etc. All right. We're going to use the lrange command. Lrange takes a start index and an end index. Okay. That's all there is to it. This will return me the latest 2 that I've put in there, from the first index to the next index. If we've already dumped the output of this, we're going to basically see whatever values we put in exactly like that. Okay, the 2 latest. And you can throw, again, from lots and lots of different news feeds or whatever, you can just keep throwing lpushes in here. It's going to come out correctly for you. All right, so that's it, really. It's very, very simple to do. You can use this for incoming feeds, streams, stuff like that. So keeping this moving and fast is not going to be much of an issue anymore. But what about size? If we keep pushing in here infinitely, then we're going to see very quickly that it runs out of room, and that's where ltrim comes in. You can basically define a range, 0 to 2. I want to keep the last 3 stories, for instance, and it will discard everything outside of that range. It's just like a trim in a string. All right. How do I run this? I can do it with a cron. That's one way. Every hour, I trim my collections to make sure they're good. But if you're creating lots of them a lot of them on the fly, then you might get it shuffled around a little bit. So I would argue that a better method might be to just, every time you do an lpush, just immediately do an ltrim afterwards. You pay a very small amount in network overhead for doing this, but if you're in a read-heavy environment, this is not really your concern. It's very, very simple to model. This is actually a great option for notifications, because this newsfeed example is not really crazy, but imagine if I were writing the GitHub notifications page. I think you guys are familiar with this. There's really a lot of different types of information that are being pulled in here. I can see somebody created a repo. I can see that somebody started following somebody else. Somebody's commenting on a pull request. Somebody's merging a pull request. If I had to write this in MySQL, oh my God, the queries. Okay? I don't want to write this. So you could use the same technique we just showed you with the list to just, every time you're doing one of these operations, you grab the list of followers and you just push it onto a special notifications key for them. It's very, very simple to do. You can also look at it a different way and use it for sort of special caching. This is kind of an updated version of a pretty old technique. Let's say I'm on PubMed, which is a list of medical journals and articles, and I search for creeping eruption. If you had a big lunch, you don't want to search for that. Okay? But we find out that there's about 1,600 different keys here. This is going to put, even again on a small database, this is going to give you a world of hurt. All right, if you have to keep doing this, because MySQL under the hood is going to keep, dealing with 1,600 rows, even if you're only getting 20 of them. All right, and it gets worse because they can go through any number of pages. They can even change the size of the slice that we're getting at one time. So it's something there. So there's an old trick here of taking your SQL like this and removing the limit clause and changing the fields that you're selecting to get just the ID. All right. This will give us now a list of 1,600 IDs, more or less. And we can use the lpush command here to push all of the IDs. You can push multiple values in at once inside of a specially hashed value. All right, maybe it's the search term hashed, or maybe it's per session, per user, etc. And then you just have to get the limit and offset from that thing right there. So you can get just 20 IDs. You can do this in memcache, and that's the way it's traditionally been done. But here, I don't have to pick up 1,600 IDs from a single key value, decode the JSON to get the right order. I can just pick out just the 20 IDs I need. That's it. Okay, so this is how you can do even everyday search pages with a nice little cache adapter in Redis, and you can have a good time doing it. Okay, recently viewed. I want to talk about a slightly different use case. Seems similar, but we're going to pick it up a little differently here. I want to talk about recently viewed pages in the sense of how Amazon does it. You know, records that I've seen in the last week or two. Now, these are things that I looked at. This was my actual Amazon feed here. And you'll notice that this is maybe a little trickier to build than you think. All right? Because we could do this with a list like we did before. That's pretty useful. We can keep pushing into it. But we don't want any duplicates. If I have a hard time choosing between Shadow of the Colossus and Shadow of the Colossus Special Edition, I go back and forth between the page 10 times. I don't want to see those two repeated 10 times down my list. All right? So that would indicate that a set is a good pick here, actually. But we need something with a particular order. Sets have no order. I think you guys can see where this is going. A sorted set is Goldilocks. It's just right. Okay? Now, we're going to do this with a z add command, because if something has no concept of order, pushing into it doesn't make a lot of sense. You say, why z add? Well, I showed you that there are different data types in Redis. It's really, really common that every single one of them is prefixed with a particular letter to tell you what type of data type it's for. Hash commands all begin with an H. Set commands all begin with an S. Sorted sets always begin with a Z because sorted Z, I don't know. All right, so we're just going to use the z add command here. And you can see here it's almost exactly the same as lpush, but there's this extra number in the middle. And that's just the score. It can be any integer or float that you want. And we're just going to tweak this a little bit for our recent use case here. I'm going to use the key recent. If you're doing this per user, you'd say recent:42 maybe. And you're going to have a URL for our case. We're using a service-oriented architecture. Very fancy. And that's how we do it. Now the question is, how do we model the order here? We have to do it as a number. Now, you don't want to use like an auto-incrementing thing here. That's not very scalable. So the trick is that we're going to use time, the time function from PHP, because this returns a Unix timestamp. Timestamp is an order, a time specified as a number. Easy peasy. Now, if we do it several times in a row, then we're going to begin to build up a particular set with the things we've seen, first, second, third, fourth, and now we're ready to read it back out. I've browsed around enough. And we'll use zrange, just like our range command. Once again, Redis is very hard. And we'll just see the first, the second, and the third that we looked. Oh, that's not quite right. We want to see the ones in the reverse order. We want to see the latest we've seen. So we use zrevrange, where rev stands for reverse. Okay? So now we have a list very easily in basically 2 lines of code. We add a z add every time you view a page. And if we want to view it, we do a z reverse range. No duplicates, nothing else here, right? How does the duplicate handling here work? Well, it uses a cute little property of Redis, that if I'm adding something here, I've already said that Redis will never allow the next value to come in twice, not for a set. It's always array unique, basically. But if you do a z add again later in the future, then it will take the later score. So if /p/first is already in that set, then it will just update it with this latest score. In essence, the last time we looked at it. So now we can just do a z reverse range again, having viewed the first page again, and it comes out exactly in the order we want. We didn't change our code anywhere. It's just still z add and z rev range, but it does exactly what we want. Very scalably, very fast, very simple. All right, cool. All right, so this is a cute little trick, but what else can we do with this? All right, I'm going to throw some use cases at you real fast here. You can take a look at them. You don't have to understand them all, just to show you what we can do. We did zrange before, but we can also do a zrange by score, give it a low and a high score. Especially because we're modeling as time, this has some cool properties because we can calculate the timestamp for yesterday and say we want everything from yesterday to +inf. +inf is a Redis keyword when you're doing range stuff for the highest possible value, to infinity. So in essence, this shows us everything that we've seen in the last 24 hours. Okay, cool. You can also do intersections just like you could with an array intersect. And we do that with the z interstore command. That sounds a little weird, but it's z sorted set, intersect, and store. Take the values that we found in the intersection and store them in another key, because potentially you could have thousands of values. I don't want to download them all at the same time. So you can do it with this setup here. It's easiest to read backwards. We're just going to say my two keys, recent and favorite. Okay? There's two of them. You have to specify the number of how many you're passing in. And we want to find the intersection and store it in the key, oh my god, because I'm probably about to buy those. All right? And then we're just going to do a Z range. We want the 5 latest things that we're seeing, both recent and favorite. It's pretty cool, actually, in my opinion. Deletion, just like we did before with ltrim, we need to go a step further with that. We need to clean this list up. And we can do that with the zrim command. We just remove anything from the list by value. But I want to be a little smarter. I don't want to blindly trim stuff that's, when we have more than 20 values or something. I want to do it by time. And you can do that with zrim range by score, which basically says everything that falls within the score in this range that I give you, go ahead and lop it off. All right, toss it out of the thing. So we can do the opposite of what we did before. Find the timestamp for yesterday, and then we say the minimum possible value all the way up to yesterday. This will leave only stuff that we've seen in the last 24 hours. All right, so we've just evicted all that stuff. We can do a lot, is what I'm trying to get across here. Redis is not a one-trick pony. There's actually 141 commands that it supports. You don't have to know them all. They're all in the docs, they're easy to find and do, but you can do a lot with this stuff, all right? Also, time is sort of a gimme. I mean, you can model time as a score very easily, but scores can be anything. They could be averages, ratings, you name it, okay? There's a lot of companies doing cool analytics and stuff like that with sorted sets. They're amazingly powerful. So I've talked a little bit here about data modeling with Redis. I want to branch out a little bit and talk about how your architecture can benefit from just adding Redis to your stack, all right? I want to talk to you about the fact that nowadays we frequently have PHP on a server somewhere. It's our web server. We might have some Node.js running somewhere in order to do WebSockets and stuff. And finally, we might have some Python workers somewhere doing, I don't know, document conversion, things like that. We can put Redis in the middle here and use this as our communication medium. Now, once again, like we did with Memcache, we could plug in ZeroMQ, which is very cool, RabbitMQ, AMQP, all sorts of messaging protocols, Hornet. But by using Redis, just again as an 80% case, just when you're communicating with some WebSocket workers and stuff, you don't have to architect around a message broker and stuff like that. You already got Redis in there. We'll use it for communication because there's a whole lot of Redis drivers. They work between all sorts of different processes here. I guarantee you, you can go from PHP to Go to Haxe to Scala to Pure Data. I don't even know what Pure Data is. Right? It's pretty simple. This is all the code you need to do like you've seen before in order to connect to Redis and show it. I'm showing you the full code again because now here it is in JavaScript to just go ahead and get the value we just set in the last slide. So you can use this for inter-process communication pretty easily. You can even go a step further here and say pub/sub. Redis has this built in because it was such a common use case people were building it themselves before. On my PHP side, let's say I'm doing a bidding site or a news notification site. I need to push something to all the guys looking via WebSocket right now. We'll have a channel, broadcast, it goes to everybody, and a message, bat kitty. There's been a sighting of the bat kitty. And we're going to do this in JavaScript in our Node.js setup here. We're just going to wait for the message event, and we'll get the channel and the message together, and we'll just go ahead and print it on the command line. And then once we have this set up here, we'll just subscribe to the broadcast channel. And then as soon as we fire off that last slide, we'll see broadcast kitty appear right there on the page. This will go to all your workers simultaneously. You can have as many as you want listening there. It's very, very easy, very, very cool. All right? So I admit this is Redis for the everyday developer, and maybe for you this is not yet an everyday case. But maybe in a year it will be. Maybe in a year there'll be some awesome new library that needs to do, and it's maybe not entirely PHP. All right? So this is not yet an everyday case. But year, 2 years, you'll be glad when you don't have to go back to your boss and beg for budget to reorient your architecture around events because you already put Redis in your stack. All right. Last use case I want to talk about with you today real quick is worker queues. Worker queues are basically like Gearman, that I can push stuff into it, have a worker pop it off there and execute it. I'm going to show you how to build sort of a Gearman light in about 10 lines of code. All right. All we have to do is push into a particular list like we did before. This is just going to be the name of the stuff that we want to model here, the name of the task we want to run, clear cache. All right, that's all there is to it. In practice, you might use something more sophisticated, maybe a JSON blob. It has parameters about what that cache should do. Mail this guy at this email address. Or if you want to go fully Redis, you could also pass in the name of a key where you have a hash with all that structured data like I showed you before. Depends on what you want to use. And then here we go. Here's our worker. We're going to set up our Redis connection just like we did before. This time we're going to pass an argument to tell it not to time out, okay, because we may be working a long time with our connection. Finally, we're going to do a do while true loop. This is a pretty common construction for when you need a worker to never end, just keep running. And I know you're about to say, Ross, this is going to kill my CPU cycles, but bear with me. Bear with me. Here's the magic. All right? We're just simply going to get the job from Redis out of that same list, and then we're going to execute it, invoke a command, a task list, whatever. And the magic here is this brpop command. All right? Now, rpop is basically the opposite of lpush. Lpush shoves stuff on the front of your list, and rpop pulls one value off the back of your list. All right? So it's a way to keep a continuous queue going. Now, the B, on the other hand, stands for blocking. And the blocking is a cool property that if it comes to here and there's nothing to rpop inside the list, then it will wait. The client will wait. This has no performance impact on the server, but it will wait for something to come into that queue. And then as soon as it does, Redis will keep track of what's the pending worker here that gets the rpop, and it will rpop it for them. And that's what you have. So now we have the latest job for our client to execute. If there's no job right now, it just waits. And this will work for you. Seriously, you can use this to do things in the background as sort of a gear man light. Just like I said, it will just keep working for you. However, there's always a but, things break. When I say things break, I mean clients break. And when I say clients break, what I mean is that clients crash. And when I say clients crash, what I mean is that background processes, even though PHP 5.3 has gotten better about it, do have the tendency to sometimes gobble up all their memory and crash in the background. Okay? That's why we use things like supervisor D, et cetera, et cetera. The problem is with our queue here, then if you use brpop, it removes the data. It's essentially destructive. That means that if your task fails somewhere in the process of do job, then you will not be able to recover that task. It's been removed from Redis. There's no more record about what it is, what job did not complete. That's not quite good. All right? So a lot of people would think automatically what I need is a status field. And I need to update my Redis hash or my database somewhere with the fact that this job is in progress. But it's not the Redis way. The Redis way is to use multiple keys. For instance, if I wanted to add priority to my worker queue here, a lot of people would say, I need to add a priority. I need to add a priority field, high, low, medium. Redis would say probably that you should add different channels. You should add different lists, jobs pending high, jobs pending low, in order to do your status modeling. It's a little bit more complementary to how it works. And in this case, we would do the same thing. Instead of just having jobs pending, we would also have jobs working. All right? All we need now is a command that is blocking to make our workers nice and simple to implement. It does an rpop off of one list, and then immediately does an lpush into the other one. That way, if it's one command, there's no possibility for it to fail. Now, it's not like we could just use the baropola push function. Actually, we can. This is a real function in Redis. Seriously. This worker queue thing is such a common implementation in Redis that they actually added a baropola push function to make it easier for us. I know it sounds like a Greek fella, huh? No. All right, so here's the code now. All we have to do is baropola push from jobs pending into jobs working, and the 0 here, by the way, is to just tell it, keep waiting forever. And that's it. Now, we have a list of all the jobs that have been pushed off for working somewhere in persistent memory now. And that's all we have to do with it. Now, we do need to clean that list a little bit up here. So we'll say if the do job part succeeded, then we'll use the lrim command, another new command, and we'll immediately clear any value that was originally the job out of this jobs working one here. And the 0 says do it for all of them that you find. So that's basically it. All right, this will put them in there, clean them out. Now, this doesn't yet describe a strategy here for how the heck would I do, actually detect these and stuff like that. I mean, you can look and see, the date that's in the job, see if it's been there longer than an hour, and decide if you want to retry it, if you want to just mail the administrator, et cetera, et cetera. You need another process to do that. So there's a couple different ways, and that's up to you and your project. You guys have to decide how you want to do that. Now, Redis as a queue engine, though, is really, really effective. The most famous group of people doing this is GitHub, actually. Their entire queuing system is built off of Rescue, which is Redis-backed. Now, that's in Ruby, but it was ported to PHP with varying degrees of success, and they didn't have all these primitives. Baropola push and stuff weren't there when they began, so it uses a whole other system. But the fact is that you can use Redis in order to drive worker queues at very high scale, actually. So once again, this is in many cases something you don't have to go beg your boss for every time you want to install Gearman, because you've got to send an email as a background process. All right? So that brings us to the end of our use cases here today. And just a few words of wisdom, such as they can. Redis is simple and powerful. It's simple because it's powerful because it's simple. In short, keep things simple and they'll stay powerful. All right? It's also quite fun. You know, Redis gives you a small set of things that you can work with in order to model anything you need. It's a lot of fun to play with these like Lego blocks and figure out what the best solution is. Maybe I can model it as two lists. Maybe I can do it in one sorted set. Maybe I can do an intersect with the, you know, the possibilities are endless, and it's a lot of fun. It really, really is. The only thing Redis is going to ask you is to make sure that the size of your data fits within your RAM. If you can keep within this constraint, things are going to go smoothly for you. If you can't fit within this constraint, your performance is going to drop off to a degree. It's not like it's going to explode or burst into flames, but you will notice the difference, okay? Redis 2.6 is in RC phase right now. It will be amazing. There's going to be some really cool new features in there, like the Lewis scripting I talked about. Anybody who's played with Redis before and has seen the Lewis scripting now is like, could be a potential game changer for how we do a lot of common operations. It's going to be a big deal. Unfortunately, I don't have time to cover it. Redis has great docs. Use them. They're really, really cool. If I've made anything up here today look hard or complicated, that's my problem as a bad speaker. It's not because Redis is hard to use, okay? And the docs make it even easier, okay? Lastly, when do I use Redis? When do I know I've stumbled across the right use case for it? Good rule of thumb here is if it's bad for the DB, then maybe you have a good case for Redis. Look at it that way. You know, it's a complement. I've also heard this referred to as the Zoidberg rule. And I'll leave this image with you in parting as a piece of wisdom. Need alternative database? Why not Redis? So thank you very much. I don't know if we have time for questions or not. So here's my image credits real quick. If anybody wants to tweet that to Sander van der Graaf, I don't mind. And here's my joined in thing. This is my very first talk at a conference, so I'm sure there's things I can fix. Please leave me feedback. If it's not, if there's nothing you found that I can fix, please leave it anyways, because that will help me go to other conferences. Okay? So thank you very much.
DPC Radio is a production of iBuildings. The materials presented are copyright of the speakers. This episode is released under a Creative Commons Attribution, Non-Commercial, No Derivatives 2.0 license. iBuildings is a full-service web development company specializing in PHP development. For more information on how we can help you with your next web project, visit our site at ibuildings.com. Thanks for listening, and we hope you'll join us again for DPC Radio.